Hello and welcome to Digital Grid. Digital Grid is a module that requires some math, so make sure you're comfortable with some basic addition and subtraction before you step into this module. So this is what the module looks like. You've got a 5x5 grid of squares, each with a number and a color. I have colorblind on, which is why you have the letter beside the number. A check button, which acts as your submit button, and a reset button, which as you select squares, which is how you'll solve this module, pressing the reset button will deselect all squares. So, first of all, we're going to write down all of the information we have here in the module, as well as all of edge work, because we will need most of edge work during this module. 2-in-1 unlit bulb. Ah yes, unlit cart, my favorite indicator. Serial number 070 Delta Quebec 3. Why do I keep forgetting to turn off pacing? Okay, so we are now going to write down all of the numbers on the module. 38395 28416 64475 and 59413, and all of the colors: yellow, cyan, white, yellow, red, green, yellow, yellow, white, cyan, blue, white, blue, red, magenta, white, blue, white, red, blue, and white, magenta, white, cyan, magenta. Alright, we'll not need to look at the module for the remainder of this example. So, we simply go through these steps to get a final value to look up in this table with a few rules. So, if the value you get ever exceeds 9, take the digital root of the number. Digital root refers to an operation where you add up all of the digits of a number until you have a one-digit number. So say you have the number, for example, 1, 2, 3, 4. Actually, no, we're going to do 1, 2, 3, 9 for sake of example. You would do 1 plus 2 plus 3 plus 9, giving you 15. Then 1 plus 5 to give you 6. So 1, 2, 3, 9, the digital root of 1, 2, 3, 9 is 6. So, first of all, we need to get the digital root of all of the numbers on the module. Note that there can be zeros. I just happen to not get any zeros in this example, which is kind of nice, actually. So, we're just going to plug all of these into a calculator. 38395 28416 64475 59413. Alright, so final number is 122. However, like it said, take the digital root of all of the numbers. So we take 122, do 1 plus 2 plus 2, that gives us 5. So the first value after step 1 is 5. Now we add all the digits of serial. So we can completely ignore 0 since it doesn't change it. 5 plus 7 plus 3 is 15. The digital root of 15, once again, 1 plus 5 is 6. So after step 2, we have 6. Add the digital root of all of the red numbers on the module. So we look down here to our colors. You can note it however you want. This is just how I note it. I'm actually just going to put 6 here, just to not confuse myself. So, we have, we just look at where the reds are and look at that corresponding position in the above grid. So the digital root of all the red numbers is going to be 217, which is 10. 1 plus 0 is 1. So we add that to 6, which is 1 and 6 is 7. Step 4, add the digital root of all of the yellow and green numbers. So simply, if you're using Notepad, you can just highlight one of the letters that corresponds to the color, and it shows up where all of them are. So we digital root all of the yellow numbers and green numbers together, remember. So 2, 8, sorry, 9, 8, 3, 5, and the green numbers being only 3. Yeah, yeah. 28. Once again, digital root 2 and 8 is 10. 1 and 0 is 1. So we add 1 to 7, which is 8. Step 6. Add the number of batteries times battery holders. 2 times 1 is 2. We add 8 and 2, which is 10. Digital root of 10 is 1. Then we add the number of white numbers. Notice it doesn't say add the numbers of all of the white numbers. It just means add the amount of white numbers. So in this case, we've got 1, 2, 3, 4, 5, 6, 7. So we add 7 and 1 is 8. Right on the 7? 2, 3, 4, 5, 6, 7. Yes. So 8 is our final value after step 7. So, using this table, we use the column of 8 and the first rule that applies. Exactly one row or column contains exactly one color, meaning that exactly one row or column is only one color. That is false. There's an even amount of magenta numbers. Well, we have 3, so that rule is false. There are more blue numbers than yellow numbers. Blue numbers, we have 4. 4. And yellow numbers, we have 4. So that is false. There are no red numbers is false. The digital root of all cyan numbers is even. So we look at all cyan numbers, do digital root of them, which is 4, 5, 1, which is 10, which is 1, so no. Exactly 2 white numbers. No. All colors in at least all oh my god, I can't speak. All colors in at least one row or column are distinct. Let's see. Yes. As in, there's no duplicates in at least one row or column, and there are no duplicate colors in column 2 here, so this is our row. And we look at the intersection of which letters we have, of what letter we have, and the intersection of the final value and the first applying rule. Look at that rule. So in this case, it is golf, any row or column that the rule applied to. So this is kind of not the best rule, because you have to look through all of them, but it's also not that bad. So that has a duplicate, that doesn't have a duplicate, that does. Okay, so it only applies to column 2. So we select all of column 2. Just make sure once again. Duplicate, no duplicate. There's whites, reds, that's duplicated, yes. And once we're done, happy with our answer, we press check. The module solves. That is digital good. I will not be doing another example, as it is just more of the same. This module is fairly error prone, but not very hard. In principle, it's just hard. It's easy to mess up. If you accidentally mess up a digital root or something, or mistype a number. So I hope this tutorial helped, and thank you for watching.